Okay. We have been talking all about these polynomials. And yesterday we worked with, if I gave you a polynomial, being able to factor it if I didn't give you the first zero. And we had that rational zeros theorem, which is great, but sometimes you don't have to use that. There was at least one example I know yesterday where it wasn't necessary because we actually had factoring techniques that could have helped us solve it. So in this section, I just want to refresh some of the techniques that we've had from the past that you could solve problems nicely by factoring, and just kind of refresh your memory on those. So for instance, let's say I gave you this polynomial. X cubed plus 3x squared minus 4x minus 12 equals 0. I want you to solve it. Now, you absolutely could do the rational zeros theorem, like I did yesterday. We can do our P's and Q's, make a list of possible zeros, look at the graph to narrow it down, and go from there. Or, does anyone recognize something else we could do here? Grouping. Remember when we did factoring, if we had 4 terms, we tried grouping? You put the first 2 together and the second 2 together. However, can you put a minus in between? No, so we would make this a negative 4. We never put a parenthesis following a negative sign. No, you would change it before you added the parenthesis. That way you're not changing your original problem. So then we factor each parenthesis. What can you pull out of the first one? And the second one? Negative 4, yeah. Okay, so you could have just taken out a 4. You could take out negative 4. Remember, the goal for grouping is for these 2 parentheses to match. So I need to take out negative 4 so that both of those were an x plus 3. Then, since those match, what we're going to do is factor out the x plus 3. If I take it out, what would I be left with? Square root. Is that completely factored? X plus 3 is good, but x squared minus 4 we could break down. Okay. We have our factored form. So now, can you solve it? Can you tell me the things that make it equal 0? Negative 3, 2, and negative 2. So if this is an option, it's faster. Does grouping always work? No. Only if, after you make your groups, you get 2 identical parentheses. So grouping isn't always going to work, but it does sometimes. Alright, let's graph this. So bringing back some of the old stuff. This is degree 3. What's my end behavior going to be? Down, up. Good. I found my zeros are the numbers we just found, right? My negative 3, my negative 2, and 2. None of those have a multiplicity of 2, so is my graph going to bounce or go through on all of those? Through all of them. Okay. Let's do a y-intercept. How do you find that y-intercept? Okay. So if I go to my original and make all of my x's 0, we get negative 12. such as -12. Okay, we said in behavior was down, up, so starting down here, ending up here, going through all of those. Hit it, go through. So something like that. How could you kind of check yourself and make sure you were correct? Okay. This one okay so far? I'm going to ask you a couple other questions. Can you look at this graph and tell me where the polynomial is greater than 0?
In between -3 and -2, and then from positive to negative.
We know it equals 0 at -3, -2, and 2. Greater than 0 is just above the x-axis. So this little piece and that piece are both above. If I wanted to answer that in integral notation, this doesn't have an equal to, so we would do parentheses. The first one was -3 to -2. The second one starts at 2 and it goes forever, so that's infinity. Last question here. Where is my graph less than 0? It's the opposite. So where it's below the axis, so that's here and here. So if we write the interval, the first one is coming from -infinity to -3. Between -2 and +2. Good. So when do we try grouping as an option for solving these?
When there's 4 terms.
4 terms. That's when you check for group. Any questions on this one? Really, it's all things that we've done before, just kind of pulling it together. We did factoring way back at the beginning, we did the graphing right before Christmas, we're kind of putting it all together now. Let's look at this one. Alright. Do I have 4 terms here? No. So graphing, or grouping is not an option. What else could we do then to factor that?
Subtract the x's.
First step to factor is always greatest common factor. I have 3 terms here. If I look at the 3 terms, all of them have an x squared. So let's pull that out. If I take out x squared, I'm left with x squared minus x minus 6. Good. Is it completely factored? No. X squared, I can't do anything else with that, but the inside I could try box method. It's a 1x squared, so we could use the shortcut. X squared breaks into x. Multiply to -1, add to -6. Can we get our solutions now? X squared, what makes that 0? 0, but because it's squared, I'm going to put multiplicity 2. X minus 3 would give me a 3. X plus 2 would give me -2. Notice the original was x to the 4th, so that means I should have 4 zeros, and I got them. 2, 0, 4 twice, 3 and negative 2. Okay, so graphing. On a test or quiz, I would probably kind of break this down. Instead of just saying graph, I would ask you the questions. What's your end behavior? What are your zeros? Is it going to bounce or go through? So let's answer those. The end behavior, it was x to the 4th, so it should be up. The zeros, that's what we just found on the last question. 0 multiplicity 2, 3, and negative 2. Bounce or through?
Bounce or through.
Right. We'll bounce at the 0 because of the multiplicity of 2 and go through the others.
How does that work though? Because the y number is supposed to be negative 6.
It won't be. You plug in the 0.
Okay.
So y-intercept, if you make all of your x's 0, you get 0 minus 0 minus 0, which is 0. I'm going to hit my x-axis at 0, 3, and negative 2. Should start up here and end up here. My y-intercept is also 0, so we've got that. So we're going to come down at negative 2 we go through, 0 we bounce, 3 we go through. And how could you double check yourself? Graph it. Look at your graphing calculator and make sure. Questions here? Okay, so let's answer a couple more. Where is this graph greater than 0? Greater than means above the x-axis, so that's here and here. You have to list the x values, small to large, so negative infinity to negative 2, and then 3 to infinity. Okay, the next one, think carefully on. It's kind of a bit of a trick to this one. I want to know when it is less than 0. So it's below the x-axis here and here.
Negative 2 to 0, 0 to 3.
Right. Negative 2 to 0, and then 0 to 3. Why did we break it up at 0? Why didn't we just say negative 2 to 3?
Because it is 0 and it's not asking much greater than.
Right. At 0, this equals 0 itself. I only want when it is less than 0. If I had had an equal to on this, then you could have gone negative 2 to 3. But I'm asking when it's strictly less than, not equal to, so we had to break up the two pieces. Alright, good. Questions on that one? Think we could try one? Once you just solve it and catch some of those mistakes. First step, you distribute. Now, if we're going to solve it, we need to set it equal to 0. When you do that, we have to subtract those terms over. And I'm going to go ahead and write them in decreasing order. So I'm going to do my x cubed. I'm going to subtract over my 2x squared. I'm going to subtract over my 27x. And I've got that plus 18. Now it equals 0. So now we can try our grouping. When you do your grouping, you can't put a parenthesis after a negative, so I'm going to make that a negative 27 in my parenthesis. What can you take out of that first group? That leaves you with 3x minus 2. Second 2, we could take out negative 9. That leaves us with 3x minus 2. So now we take out the 3x minus 2. We have x squared minus 9 left. Does that make sense? I think a lot of you weren't putting it in decreasing order, and so your grouping wasn't working. Am I done factoring? Okay, so now if you set each one to 0, you get for the graphing, I'm going to ask you about end behavior. So I would just look right here. My highest power is x cubed, so x cubed would be down, up. My zeros we just found, that's the 2/3, -3, and 3. All of those have a multiplicity of 1, so our graph will go through all. Y-intercept, if you plug in a 0 for all of your x's here, what do we get out? 18. It would be 0 minus 0 minus 0 plus 18. Behavior, down, up. Okay. So starting, go through all of them. Okay, the y-intercept, come down, go through. What's your next one? So our graph looks something like that.
Can you explain that in behavior?
Yes. So end behavior is based on degree. You look at the highest degree in your problem, so the highest exponent. If it is an odd degree, you are thinking about x cubed, which we know is our chair function. So it's going to be down, up, as long as it's a positive coefficient. We know if you throw a negative out in front of anything, it flips it, so it's up, down if it is a negative coefficient. Even degree, so if our highest power is an even number, think about x squared, that's our parabola. So both ends are going up if it's a positive. Negatives flip it, so both ends go down if it's a negative coefficient. The nice thing about end behavior, if you're not sure, you could always graph it and look at the graph and decide from that as well. Other questions there? Let's try just a couple more, make sure we've got our strategies. This one's a little bit different. It's not 4 terms, so I'm not going to do grouping. We could do P's and Q's still, and that would work just fine. There is another option. So if you're stuck, do P's and Q's. We can't, do we have a greatest common factor on this one? No. We can really factor this by using box method. We're used to box method being x squared, x, and a constant. This one is x to the 4th, half of 4 is 2, x squared, and a constant. So it's really like a quadratic, but slightly different. So let's see, it's a coefficient of 1, so let's see if we could just do 2 parentheses. X to to the fourth. If you have 4 x's, what goes in each? X squared. Okay, multiply to a negative 40, so we need a positive and a negative. What multiplies to negative 40 and adds to negative 6? Positive 4, negative 10. Let's check to see if it works. If I multiply this out, x squared times x squared is x to the 4th. Minus 10x squared plus 4x squared is negative 6x squared. 4 times negative 10 is negative 40. So it does work. Okay. That'll be the case anytime if you're looking at your x's. If you have 3 terms, the first one, if you take half of it and it gives you the second one and the last is constant, this strategy would work. But again, if you don't like it, you could always do p's and q's and that's still going to work.
So
Okay.
like the p's and q's thing will work for anything?
As long as you have a constant term. It's like the problem where this one, the p's and q's wouldn't work because we don't have a q value. Or sorry, we don't have a p value. Okay. How am I going to solve this then?
Did you break each parenthesis and like, oh no, because it's not a positive 4. I mean,
Does that make sense?
yes.
Yeah, it's a positive, so you can't do difference of squares. So if you do square root plus and minus, you get plus and minus 2i. This one, 10 isn't a perfect square, so you could do difference of squares, but it's going to be a little ugly. We could just solve it. Can you break down the square root of 10? I get plus and minus radical 10 on that one. Okay. Let's talk about our graph just briefly. What would my end behavior be? It's a positive x to the 4th, 4 is even, so both ends are going up. The zeros are the x-intercepts. Can you graph positive and negative 2i? No, so you could list them here, but you don't have to if you just want to put the real ones. We have positive and negative radical 10. Both have multiplicity of 1, so it'll go through. What's my y-intercept? Right, if you put in 0 for the x. 0 to the 4th, minus 6 times 0, minus 40, is negative 40. Okay, to graph this, we need to approximate. If you type the square root of 10 in your calculator, let's give it decimal so we have an idea of where to graph it. And that's like 3.16, negative 3.16. Both ends are pointing up. We're going to hit those zeros and go through. So we're going to hit this, go through, down hit our negative 40, this and go through. So our graph looks something like that. The eyes didn't impact your graph because we aren't graphing the imaginaries here. Okay. Where is my graph greater than 0? We know what those points are exactly because we have the radical form. Greater than 0 is above the x-axis, so that's here and here. So less than 0 would be in the middle. So that's from negative to positive. And of course, if you're not sure about something or want to double check, put it in your graphing calculator and confirm that your graphs match. questions there? I want to do one last problem, I think, and just make sure you guys can factor this. What are we going to have to do first? If it didn't have the x over here, you could set it equal to 0, so subtract that over. Okay, first step to factoring, what do I need to look for?
Common.
There's common factor. What can I pull out? Right. This can break into x plus 6, x minus 6. So my solutions, this one is 0, but we'd have to write multiplicity 2. X plus 6, that'd be negative 6, and x minus 6 would be positive. Alright, so make sure you're always setting these equal to 0 to begin. So really our strategies that we've looked at, grouping, greatest common factor, and then we had that one that was kind of like a quadratic but a little bit different. Okay. Do you need extra problems on anything? Alright, now I'm going to go ahead and let you work. There is a Math Excel assignment. Tomorrow you will have class time.